Understanding this, so I'm really happy to have heard Eric's talk because it comes back to what I'm basically going to be talking about. I'm more of a network manager rather than a scientist, although I have a background in science and I have some history with understanding what all this data means and so on. But really, I'm a network manager, I'm an operator. And I work with a bunch of people out of Victoria and the rest of the province of British Columbia to get information together to improve the climate record in British Columbia. We collect observations. First understanding of changes in climate or understanding climate came from observations, and then we started to get those trends in those observations, and that started us down the path of, well, let's see if we can do with modeling that information and running those models then over time with perturbations in the information so that you get understandings of what's happening with climate change. This talks more about collection of the observations rather than the actual model runs. So you're likely familiar with these two pictures. They're prism maps of continental US and of Alaska. A lot of the maps that I've seen over the last few days have appeared to stop almost there, and so that there's almost like dragons up in Canada. There's not. A lot more of the maps have also shown all of North America or the globe and so on, but there's this gap that we have between the US and the provinces of Canada where data stops somehow or analysis stops somehow, and we're here to try to get over that boundary. Up to the last few years, there's been problems with getting access to data from various jurisdictions. BC's made some leaps forward in this, and I hope to talk to you about that. So here's the province of BC in the nice light background. We're influenced by, of course, the continental Arctic air, continental air, and also the maritime boundaries. So we've got a lot of interaction between those two different environments or two different air masses that causes a lot of weather. Here be mountains and valleys, and here be more mountains and valleys is basically what this is showing. We're a complex province. We have space. We're about 945,000 square kilometers of land, 4.6 million people. So if you want to have an American analog for that, that's about 3.5 times the size of the state of Oregon and about the same population, a little bit more. So we've got a lot of area to cover in comparison to a lot of other jurisdictions with less population. So we share boundaries, of course. We've got the American continental US boundary on the south part of the province, and we've got the Alaska Panhandle on the northwest corner. Of course, we also think about Yukon and Alberta provinces sometimes. BC is a little bit centric in that way. But of course, we're sharing weather conditions, and the weather conditions lead to changes in climate or understanding what is actually happening with climate, and it spans boundaries. So it's just the way things happen in this part of the world. I'm going to go through these next slides a little quickly. This shows you sort of the history of weather observation platforms within the province. You'll notice the first bit is fairly valley bottom centric, if you will. We were trying to do agricultural studies and understand what the arable land was in the province. But as time built out, the network sort of changed over time, and this is pretty much what it's like today. So anything red is run by our federal counterpart, Environment Canada. Anything in any of the other colors is run by a provincial network or a provincial agency or a private company. You notice we have two fairly gappy areas. They're not necessarily well filled in up in the north and along the central coast area around Bella Coola, and that's a real problem for us. We have these gaps. We don't have the population, and yet we have to understand what's happening with climatology in these areas and how that's going to be impacted. Looking at sort of the elevation distribution, the DEM refers to sort of the amount of land mass, the percentage of land mass, if you will, that's in each of these sort of elevation bands across the province. The 100 refers to 0 to 200. The next one is 200 to 400, et cetera, all the way out. When you look at Environment Canada and the provincial networks, they have a fairly different distribution. Environment Canada is focused on public weather and public safety issues. The provincial networks are focused in on safety issues, but safety issues not necessarily in the public areas. So we're looking at things like avalanche forecasting, we're looking at things like fire weather forecasting and so on. Who are we? Well, we're the Climate-Related Monitoring Program, and I'll just go into some few little stats here before I go there. We're a consortium of public, crown corporations and private meteorological operators whose mandates to deal with their respective operational decision-making processes. The intent behind our group is to supplement what Environment Canada has for climate observations, because they are the ipso facto standard in Canada for who's collecting climate data and how that gets represented out to the rest of the world. So we're not there to replace them, we're there to supplement their information needs. And there's no way in hell, so to speak, that we could actually replace them because our stations don't necessarily have WMO standards or follow necessarily climate-specific standards. We're supplementing information. Our total network value is around about $10 million, so if everything burnt down across the province of BC and we had to replace all the stations, that's probably the minimum that you'd have to spend. And our operational costs are on the order of $2.5 million a year with about 23 people doing the work on the ground, plus or minus, because there's a couple of private networks in there that seems to go up and down a little bit. Who are we? We're the Ministry of Transportation and Infrastructure for avalanche and road weather. We're Ministry of Forest Lands and Natural Resource Operations for wildfire management and for Forest Ecosystem Research Network. Air monitoring, which is what I head up, and the snow survey networks from the Ministry of Environment. We're dealing with Ministry of Agriculture as well, who run the networks, a couple of networks in partnership with private agencies for irrigation and sort of crop control or crop management. We're also dealing with BC Hydro and Rio Tinto Alcan, and Rio Tinto Alcan is the lone private operator out there right now in the group, and they're dealing with getting information for for stage forecasting for hydro generation. The last member of the group is PCIC. PCIC stands for the Pacific Climate Impacts Consortium, and basically they're our think tank. They take the information and they roll it up into getting better information out of all of that data. When we look at weather observations, they're the basis for what we're dealing with in terms of getting information together. We're working to consolidate the data from all the networks into one portal. We've already created a provincial climate data set. We're trying to make it easily accessible for people, researchers, even the public to get access to. We want to use an analysis to understand and fill in the gaps in the network with model information derived from observed values. We also want to use the observation data and share it across agencies. There's a number of things that we can do to streamline operations in our networks. For example, why would we measure information at a summertime running by our weather station here when 2 kilometers down the road we also have a station for winter road weather conditions? Why not combine the two into one? It doesn't always work, but that's the idea. So what progress have we made so far? We're redoing the PRISM mapping. I talked a little bit about the PRISM climatologies for the continent in the US and Alaska. We're redoing it for BC. This is going to be for the 1971 to 2000 normals, and this was actually a pre-release of the image for precip, and it was taken up and reviewed by climatologists in the province and operational people for understanding what was going on. The big problem here is that we found some issues with the coastal transition between the coastal wet areas where there was a lot of precip on the coast and the high mountains. But we're not just redoing the PRISM maps, we're actually taking the PRISM technology and we're moving it to BC, or we're taking a copy of it and working with the PRISM group out of OSU to make the product more robust, make it more open, make it more usable by other groups. So we're doing that. So we've discovered this problem with the mapping as it is now for the transition areas, and we think that's in part because of the lack of stations that we have in those coastal areas. So what Farron Anslow did, who's the lead at the PCIC on this project, is he also understands there's a relationship between summertime temperatures and the equilibrium line of glaciers. And so he took that relationship and he applied it so to get a better estimate of the winter precipitation. And that actually brought what it was showing on the map, or in terms of values for precipitation on an annual basis, brought it up to a more realistic what we expect to see for that environment. So not only are we taking the PRISM technology, or taking a copy of the PRISM technology north, we're actually working to improve it in ways that maybe could be applied elsewhere. We're also opening up the data access. We have a portal, and this is probably the first thing that's been done in Canada with respect to this stuff. I don't know what the state is down in the US. So we have a portal that's available. We can get data down from anywhere from 1880, which is when our data collection processes actually started, up to present, or up to about, now it's 2011. We still have to upload the next two years of data into that. You can query these tools. This is for the current set. There's actually a date range in there. So you can actually query the data by date range. You can query the data by climate variable you're looking for, by network name, by observation frequency, and you can get downloaded data fairly readily. You can either look at the metadata for all those stations that you've queried, and then download all the data, but it's not recommended for the whole province because you get a SWAC of data and you'll slow the servers down. or you can look at polygons of areas. So you can actually pick out a polygon and say, well, this is the area I'm interested in. How many stations are there? When were they running? And get all the information that you need out of that. So that's a huge step forward for BC, to get all that data together from all the different networks and put it into one spot where people can actually go and collect it. So we're also looking at interpretation. We're looking at seasonal climate reviews and getting information back out to the public that makes more sense in a more near real-time analysis process. We're doing seasonal climate reviews based right now on Environment Canada data, which, like I mentioned before, is the ipso facto standard in Canada. The intent is to incorporate in more of the other networks like Ministry of Transportation and Ministry of Forests to get a better picture of, fill up some of these gaps. We're working in what we call eco-provinces, and so, you know, there's not a lot of representation, and until we improve that, we really probably won't have a good set of images or information for this area. But as soon as we get that live data feed coming in from those other agencies, then that will improve. This is an example that Trevor was talking about, Bella Coola, the atmospheric river that happened over in September of 2010, where Bella Coola basically got a 1 in 200 year storm. An atmospheric river just decided to park over top of Bella Coola and start precipitating out. And so you can see that down here in this area a little bit where you've got some really dark triangles just right over the transition line there. But it was generally a wet September for the rest of the province, but this was a huge event. This was like on the order of 250 millimeters over 40 hours, over the first 40 hours of the storm, which, you know, I guess that would come out to about 10 inches. The next one is the Calgary event, which happened earlier this spring, and I'm not sure if anybody here heard about the Calgary flood event, but basically it's almost stopped the stampede. And so that's a pretty big thing to do. Calgary Stampede's a very famous tourist event, and we had a huge rain event down in sort of the southwestern Alberta and in southeastern BC. What everybody heard about was a Calgary event where we had 200 millimeters of precip go over top of, was it 200 millimeters? I'm sorry, that number might be wrong. But it went over top of saturated ground. The ground was already wet, it was already saturated. There was no room for more percolation to happen in the ground, and it just flooded all the river valleys. And multi-millions of dollars worth of damage in Calgary. High River was shut down. There's a reason why it was called High River. And then down in southeastern BC, though, which you didn't hear about, where we have a few people, but not a lot of people, there was also major issues happening with road closures and almost communications corridors being shut down. So, you know, we're trying to get this information together. We're trying to put out more readily available products. People can actually see, is this an anomaly or not in the longer term? And we're reproducing, we're getting this information out in a different format than what our federal counterparts would do. Challenges. Data sharing between agencies is always a challenge. What we don't have is a data aggregator or annotator. We can deal with format. We could set up a format, standard format. We could set up timing for how that information comes in. We can deal with communications issues between agencies, but that's making one agency talk over here to this one over here to this one over here to this one over here. We don't want that. We want a central process. And so what we want to go to is somebody that can do data annotation and do quality control, and that's where we're looking to our federal counterparts to deal with at this point in time. We're trying to streamline the networks. We've got problems with precipitation technology. We're dealing with different types of technology for measuring precipitation out there that aren't necessarily as robust as we would like them to be. Of course, measuring winter precip is never clean, as we saw on the slide earlier today. You get capping, you get all sorts of funky issues in the gauge and so on. But you can also streamline the technology or streamline the network so that you can deal with streamline the observation locations so that, you know, you can bring those stations together, and then you have the power. Well, you have now infrastructure for another station. Can we actually put a station in the gappy area where we don't have information? And then we just heard it from Eric, metadata, consistent approach on metadata. Not all networks have good metadata about their station operations. It's hit and miss with some of the private networks. And even the public networks, we don't necessarily keep really good records on that, and that's a problem that we're trying to face. So future works, we're going to continue to work with the PRISM group and get better climatologies out for the province. We're working on the 1970 to 2000 normals. We're going to actually recalculate the 1960 to 1990 normals. We're going to move on to the next set of normals, et cetera, so that we can get a better picture of the change in the climatologies as PRISM sees it over the course of the province, but also give better results out to our end users. Of course, that will help improve the back end of Climate Western North America and other people who are using tools for looking at a seamless coverage on the West Coast if Alaska gets redone. There no longer need to be dragons out there, right? We don't need to have the dragons going. There no longer needs to be the gaps. If we can set up a central portal to get information through, then we're good. And people can come and get that information. It doesn't necessarily have to be a member of the consortium. Data aggregation and annotation, I talked about this. We don't have a single standard for data quality control. We're trying to work that through and get that in place. But we really need the real-time sharing of one point of contact for that information. And we're always open to talking to more agencies for information. Better metadata. So one of the other things that we're trying to do is incorporate WMO's WIGOS into our observation characterization, if you will, so that this might be a really good precip site over here because it's below the valley ridge or it's in a forested site, and so it's fairly representative of that environment. This might be a really good temperature site over here because of similar concerns. There might be a really good wind site at mountaintop. So, you know, just trying to characterize a site, what is the best set of data from those types of stations. In summary then, there no longer need to be dragons. Operational data is being used to supplement the climate data, and we're working together to improve that. And I think that's the last bullet. Yeah, we're working to improve the observation quality and associated metadata so that they can be better data for use, to verify, get the model runs, to use in looking at new or incorporating different methods and analysis and so on. This paper was put together actually by about 5 people, and the useful links are down below, which you will be able to see off the website, I imagine. And again, that's who we are. Thank you very much.